Hello everyone, I am Kushagra Jain and today I will be explaining Hadoop, the backbone of big data. In this presentation, I will walk you through what Hadoop is, why it became essential, how its architecture works, its major components, applications, advantages, and limitations. Before we understand what Hadoop is, let's first understand why Hadoop was needed in the first place. Today, organizations generate massive amounts of data every second from social media, e-commerce, sensors, and financial transactions. This data isn't just large in volume, but also moves very fast and comes in various formats. Traditional databases struggle with these large, fast-growing, and unstructured data, leading to high costs, difficulty in scaling, and inefficiency. So there was a need for a framework that could store large amounts of data cost effectively, process data in parallel across multiple machines, recover automatically from hardware failures, and remain open source and scalable. To solve these big data challenges, Apache Hadoop was developed. Now that we know why Hadoop was needed, let's move on to what Hadoop actually is and how it began. Hadoop is essentially an open source framework for distributed storage and processing of large data sets using clusters of ordinary computers. It was inspired by Google's file system and MapReduce model and created by Doug Cutting and Mike Caffarella. Hadoop was quickly growing thanks to the support of big tech companies. It became the foundation of big data analytics, providing a cost effective and reliable way to handle massive data volumes. Today, Hadoop powers data processing in industries like finance, retail, healthcare, and social media. Now that we know what Hadoop is, let's explore how it actually works, starting with its architecture. Hadoop's architecture has four main components: the Hadoop distributed file system, MapReduce that handles data processing, yet another resource negotiator, Yarn, that manages resources and schedule jobs, and finally Hadoop Common that provides the core libraries and utilities. Each layer works together to enable distributed computing across a large number of low-cost machines. Let's look at each of these components one by one, starting with the most important Hadoop Distributed File System, HDFS. It stores huge files across multiple computers in a cluster. It breaks large files into small blocks and distributes it among multiple machines for faster access and storage. It has basically two major components: the name node that centrally manages the file system metadata and directory structure. And secondly, the data node, where the actual data blocks are stored on physical hardware. So basically, each block is replicated across different nodes to ensure fault tolerance, meaning if one node fails, your data still remains safe and accessible. Now, once the data is stored safely in the HDFS, we need one way to process it efficiently, and that's done using the MapReduce. MapReduce is the Hadoop's parallel processing model for analyzing data in parallel. So, the first stage in this process is the map phase, which breaks down the input data into small chunks and then filters and transforms each chunk independently. Next comes the reduce phase. It aggregates and summarizes the results from the map phase to produce final outputs. For example, in a word count problem, the map phase counts words in small files, and the reduce phase adds them up to get the total count. This parallel processing makes Hadoop extremely efficient with large data sets. Now that we know how data is processed, let's see how Hadoop manages all its computing resources using YAR, which is yet another resource negotiator. This is responsible for managing and scheduling cluster resources. It basically performs two main functions: the resource allocation, which means it distributes CPU, memory, and other resources to the running jobs. And secondly, the job scheduling. It makes sure that multiple tasks run smoothly and efficiently at the same time. Yarn made Hadoop much more flexible, allowing not just MapReduce but also other big data frameworks like Apache Spark to run on the same cluster. So now we have seen storage, processing, and resource management. The next component is what connects them all: Hadoop Common. Hadoop Common, also known as Common Utilities, includes the shared Java libraries and tools that all other Hadoop components rely on. It handles the file input output operations, the configuration, logging, security, and also the network communication. It also manages hardware failures and includes built-in tools like Hadoop Archive and native libraries. In short, Hadoop Common acts as the foundation that supports the entire Hadoop framework. Beyond these core components, Hadoop also includes a large ecosystem of tools that extend its functionality. Let's take a look at them next. The Hadoop ecosystem is a collection of tools that are designed to make big data handling easier and more powerful. It includes some key tools like Hive for SQL-like querying on large datasets, Pig for data flow scripting and analysis, HBase. It is a NoSQL database for random read-write access, Scoop for importing and collecting data from external resources, Zookeeper for coordination, Oozy for work scheduling, Spark for fast and real-time analysis. Together, these tools make Hadoop a complete big data ecosystem, not just a storage and processing framework. Now that we have seen how Hadoop works, let's see how it's actually used in the real world. Hadoop has become a big part of data processing across many sectors like social media and internet companies. So, Facebook, Twitter, LinkedIn use Hadoop for analyzing user interactions, trends, and recommendations. Amazon and Flipkart use it for analyzing customer behavior and detecting fraud. In banking, it helps detect suspicious transactions and risk management through real-time data analysis. In healthcare, it analyzes patients' data for disease prediction and research. And in telecom, it processes call data to improve service quality. Now let's see some advantages of Hadoop. It offers various benefits like scalability. It easily handles data growth by adding more machines. Cost effective. It runs on affordable commodity hardware. Fault tolerant. It automatically recovers from failures. Flexibility. It processes structured, semi-structured, and unstructured data alike. High throughput. It supports parallel processing for faster analysis. And it is open source. That is, it is freely available and supported by a large developer community. Of course, like every technology, Hadoop isn't perfect. So here are some of its limitations. The first is suitability for only batch processing, not real-time analytics. Second is the complex setup and management. It requires expertise to configure, monitor, and maintain clusters. Third, high latency. It can be slower for tasks that demand immediate response. Security concerns. They are basic and they often need extra configuration, and it's resource intensive. That is, it consumes a large amount of memory and disk space for large jobs. Even with these challenges, Hadoop remains the foundation of big data systems today. To sum up, Hadoop revolutionized how organizations handle data. Its distributed storage, parallel processing, and powerful ecosystem have made it the core of big data analytics. Although newer tools like Spark are emerging, Hadoop remains the foundation that supports them. As the saying goes, without Hadoop, big data would just be a big chaos. So that is it for the video, and thank you for listening.